Happy day for my dear students and my viewers. So in the previous class we were discussing about the operational amplifier because operational amplifier is going to be going to play a major role in the bioamplifier and the signal processing. So one of the application of operational amplifier is differential amplifier. It is in our syllabus. That is why we are going to discuss about that one. In some, actually, there are many applications, but as far as our curriculum point of view, and it is enough to discuss only differential amplifier, instrumentation amplifier, and chopper amplifier, and isolation amplifier. So now we are going to discuss about this operational amplifier. So a differential amplifier, as the operational amplifier consists of two input and one output. The two inputs were V1 and V2. It is connected through the resistor R1 and R3. Okay, V1 R1 into inverting in terminal 2 and V2 R3 to terminal 3, that is non-inverting, and this non-inverting terminal is connected to the ground through a resistor R4. Okay, the output is taken through in the pin 6. Okay, but it is necessary to provide feedback through the by connecting this terminal 6 and the terminal 2 through the resistor, feedback resistor R2. Okay, now let me give a small description. V1 is the input of inverting through the resistor R2. V2 is the non-inverting input through resistor R3, and R4 is the ground resistance, and V out is across in the sixth pin, and R2 is the feedback resistor. Now we want to get the outputs V out. Okay, so V out formula is, that is R1 plus R2. Okay, R1 plus R2 divided by R3 R4 into this R4 divided by R1. Okay, into our input terminal V2. Okay, minus V1. Okay, V1 is R2 divided by R1. Okay, so this is our output equation. But in many cases, we will be taking the equal value of the resistance R1 and R3, okay, R2 and R4. The reason is so that there won't be any difference in current flow. Okay, the reason is there won't be any difference in current flow, and it is easy for the calculation and analysis purpose. Okay, it will be easy for calculation and analysis purpose. So maximum this R1 and R3 will be equal, and R2 and R4 will be equal. So if we substitute this equal value R1, R3 and R2, R4, the final output equation is rewritten as V out equal to R2, R1. Reason is R1, R2, okay, and R3, R4 both are same. Okay, R1, R2 is same, R3, R2, R4 is same. So if we manipulate this one, it will become 1. Okay, and see here R4 and R1, here R2 and R1. So in this equation R2 and R4 were denoted as same. So if you replace this R4 by R2 over here, then R2 by R1 into V2 minus R2 by R1 into V1. So in this equation R2 by R1 and R2 by R1 will be common. So now we take this R2 by R1 outside and V2 minus V1. Okay. So for minimum offset error, this R1, R2 is equal to R3, R4. Okay, so this is to be considered. Next, this op-amp is how implemented in biosignal analysis, that is biosignal manipulations. Okay. Now let us look at that one. Okay, so now if you look at this slide, you can come to a conclusion that this is actually the connected in ECG mode. Okay, here the patient, the subject is connected in ECG mode for the waveform analysis. But here ECG mode is shown. Okay, actually this setup is ECG setup. This patient operation amplifier CRO alone is ECG. But if you look at this earth rod, okay, if there is an earth rod, as I said in the previous class, if there is no proper earthing, okay, then that will create hazards. Okay, which type of hazard? Shocking hazard to the patient. So all the beds and the electrical equipments will be grounded, properly grounded, and that grounding should be maintained at very low resistance path. Okay, less than 1 ohm. But here, if you look at this, there is a capacitance between these fixture. Okay, fixture is nothing but lights. Okay, if you go to an hospital, you can see many fans and lights hanging over the patient bed. Okay, so that fixture is supplied with AC supply, and the patient bed is grounded to the common AC. That is the another important point to be considered. Okay, this bed and the patient is connected to the ground of AC. So therefore there is a capacitance forming between the light fixture, okay, and the patient, that is C1, and again another capacitance between these two, arm and leg. Okay, so how this is formed? This is formed with look at this. Here you can see leg is connected to the ground. Okay, this is formed by connecting the leg to the ground. So here there is a reasonable value of capacitance is formed that will give some giddiness to a severe patient. Therefore, how this can be eliminated by connecting the differential amplifier. Okay, so here the differential amplifier connection, the connection of differential amplifier is eliminating the capacitance between arm and leg. That is our main ultimate goal. Okay, so that the patient will not feel any giddiness. Okay. So one capacitance is formed between the fixture and the arm, and the discharge will take place through this service or guard wire, and another capacitance is formed, C2 is formed between leg and ground. So there is no any capacitance inside the body. So by this way we can eliminate the uh, leakage current and residual capacitance, okay, performed by the AC lines between the fixture and measuring instrument. Okay, so this is an application, one of the application of this differential amplifier. So that's all with the today's class, and we will discuss about instrumentation amplifier in the next class. Thank you.